Hello everyone. In this lecture, we are going to take a look if we have installed Pandas and NumPy correctly in our computer. And we are also going to get a detailed explanation of some of the essential attributes in data analysis for data representation. So since we are doing machine learning and artificial intelligence course, there are some important libraries that we should have a detailed or a deep understanding. For example, Pandas library, it is very important to work with Python because it helps you when you're analyzing your data in machine learning, especially when you're dealing with big data. So we are going to take a look into data analysis with Pandas library. So let us get started. The first thing we need to do is to import Pandas as PD. And here the import statement, it means we have called this module, the module called Pandas. And after calling this module Pandas, its job, this module, is to make sure that whenever data that we are going to manipulate later in our project, interpreter is going to check if the module is there. So we have to import Pandas as PD. Now we need also to import NumPy. And NumPy here, it is very important because NumPy, it helps Python programs or Python codes or any instruction that we are going to work with in our project, as long as it has to do with numbers that we can see here. So numbers are actually, numbers can work well with the NumPy. So we are going to import our NumPy library as NP. And also we are going to import matplotlib.pyplot as PLT. And here we are saying matplotlib is a collection of functions which are used for graph plotting in Python. And its main purpose is to visualize data. So here matplotlib.pyplot is a statement which acknowledges that matplotlib utility are obtained from pyplot submodule. That is why we add an extension .pyplot, and we are importing it as PLT. So in short here, we are just saying that we import Pandas as PD so that we have the module whenever we want to execute our data. Now we can run our line of code. Right, so we have run our first line of code here. Now what I want us to do, let us put this line of code numpy.random.seed, then we put 10, and also we run this line of code. Now after writing seed.10, I want us to generate random numbers here, 100 numbers. To generate random numbers, we create a variable here, then we generate random numbers. So let us run our code. And here we create a variable, and this variable is called series. And we call our Pandas, and in Pandas module we need series. Then we put the random numbers that we have generated here. So let us run this code again. So after generating a Pandas series here, now we are going to plot a histogram distribution. And here our series, which is the random numbers in series Pandas, dot plot, the kind of graph that we want to plot is a histogram. And we have added a title here called urban population distribution. Now we can run our code to visualize our plot. So this pyplot.show is to show this graph. Let us dive into seed. In our previous code, you have seen that I have written this code seed10. Probably you have not understood or understand anything about seed. So let me explain a little bit about seed. So if I run this code, I get these random numbers. This is only 3 random numbers that we've generated. If I also run numpy.random.rand3, if I run this same code exactly, I get different random numbers. But the code is the same, but I'm getting different random numbers. So what do we do? For example, I have a project that I've created in Python, and I want my friend at school to replicate that same project and get same results. It means I should use the word seed. here. So the word seed here, or this function, is part of the NumPy module, and its purpose is to reproduce the work, the word seed. It reproduces the work. So this means that it generates the same random values in your project, no matter which machine you are using, without changing or include any unexpected values in your line of code. For example, now, let us take a look into this. We write seed and we need to generate random numbers, which are 3. If you run this line of code, you can see we generated this code, these random numbers. If also we are to run this line of code, you can actually see that we obtain the same answer. So it is very important in machine learning and artificial intelligence to know how to replicate your data, so that when you are analyzing and compare the data, it is simple to maintain your data constant. So you have to apply or to use this word seed. Now, after seeing these results, I think we can now move on to our next concept, data structures in Pandas. So Pandas provide 2 useful data structures to process the data. And we have the series and the DataFrame. We are going to take a look into these 2 in this video, the Pandas series and the DataFrames. The key to learn Pandas is to understand the data structures, how the data is structured. And I said it is structured either in a series way or in a DataFrame way. And a data structure is a collection of data values and defines the relationship between the data and the operation that can be performed on the data. You have to understand how to operate or how to perform merging all the operation in relation to data structures. Now, let us start by looking into the Pandas series here. So Pandas series is a one-dimensional labeled array capable of holding data of any type. So we can say it's a mixed data type. So Pandas series is like a column in a table. So the only 2 elements that you are having there, or aspect or attributes that you will have on a series, it's index and the one-dimensional data there. So to create a Pandas list, you can use a list, a tuple, and a dictionary. These 3 can be converted to a Pandas series. Let us start by looking into a tuple. So how to convert a tuple? Remember last time on our video, we looked into tuples. So tuples are denoted by brackets. So we're having a bracket of alphabetical order or of strings. We're having a tuple of strings A, B, C, and D. So we after creating our tuple, we are converting our tuple right here when we are calling our series data structure series here from the Pandas module. Then we are passing a parameter of this variable here, a single parameter only, and we are storing in the variable that we have created called series. Now let us print our series here. So we can actually see that this is in the form of, this is a column of the data, and this is the index. So it's just a one-dimensional data. Now let us see how we can convert a dictionary to series. And a dictionary is denoted by curly braces. After creating a dictionary of string, remember on a dictionary we have a key and a value. So in this manner, we are having 4 keys, as you can see, and the 4 values. So we are going to take this dictionary and pass it as a parameter on our Pandas module or on our series data structure. Then we can print right here. Let us run our code. Right, as you can see here, this is the data that we are having. So this is the key, so we can actually see that the index of the data is the keys and the values representing the columns of the data. So you can also select a single element using the index or the index label of the series. Let us take a look on the example of a dictionary. For example, here we are going to use a square bracket. In this square bracket, we are assigning the index value of the data that we want to filter. or that we want to select. So if I run this line of code, I'm getting machine learning. So 0, 1, 2. This is the index number. So this index number, I'll get the value. And also, if I put a string course, the key, I can still get the same result. So I can use an index number, because here we're saying 0, 1, 2, 3. Or I can use a key value, a key, to get the value. And also we have what we call slicing. Slicing now, we use index number to select a range of elements from a series. And in slicing, we are saying we are selecting a range from index number 1 up to index number 3. But on index number 3, it is nothing but 3 minus 1, which gives us 2. So we are selecting from index number 1 up to index number 2. Let us run our line of code. We can see that if we are to scroll up, this is 0, this is 1, this is 2, this is 3 here. So we are supposed to get here, but how Python interpreter get the data, it is subtract 3 minus 1, then it get this value here. So it gets 0, 1, so it get only the surname and the course. This is how we do slicing in Python. And also, let us run this line of code. This line of code will give us all the data that we are having. We are saying that we need to start at 0, and also we need to do one step, and we need to end at 2. So this is the start, this is a step, this is the ending point. Now, in Pandas, you can also modify the data. And how you modify data, you just write the data, the series, or the variable that you want to, or the data set, or the variable that you want to access data from. Then you put only one square bracket, then you use an index of where you want to modify the data. For example, this is index 0, and I want to change it from Fanuel to Peter. If we run our line of code, we can actually see that we have modified our data. Same applies. We can also even add data to our series. For example, we write the data that we want to add within the key, and also equal to, we pass on the value that we want to add. In this case, if we run our line of code, we can actually see that at the end of this year, we have actually successfully added age. So we have successfully added age at the end of our given data. So this is how we manipulate data in series. Let us look into the Pandas data frame. A data frame is a two-dimensional data structure composed of rows and columns. And a data frame has two different index. Example, column index and a row index. So the data frame consists of three components, namely two-dimensional data, row index, and a column index. These three aspects or three components are very important to take note of. We have the row, we have the column, and an index, which is different from a Pandas series, which consists of one-dimensional data, which is one column and an index only. But in this manner, we have row index, column index, as well as two-dimensional data that we should take note of. And the columns should be always of the same length, but they can contain different data types. So here we are just saying series is like a column, and a data frame is like a table, a full table, a whole table. Let us create a data frame. In this case, we are going to create a variable called score. And in this variable score, we're going to create a dictionary. And in this dictionary, we are going to have a key here, which is name. And we are going to pass a list of names that we think of. So here we can see that we have 5 names. And also we have another key with a list of marks. And also we are having another key which is grade with a list of grade. So this is the dictionary that we have created. Now we need to convert this dictionary to a Pandas data frame. So we have called here Pandas module, and we need to use the data frame, our data structure, and we are passing our parameter here to convert this dictionary to a data frame. And we have stored it in a variable data frame. Now let us visualize our data frame. Okay, let us run here our dictionary first. After running our dictionary, let us visualize our data frame. Okay then. Now this is our data frame in the form of a table. And like I said earlier, it is having an index column. This is a 2D table. So in short, we are saying a data frame, it is in the form of a table, as we can see here. So since we have successfully uploaded a Pandas data frame, what I need us to do now, let us manipulate the data of a data frame. Let us manipulate the data that we are having. Let us start by filtering the columns we want to work with. So in order for us, for example, in this manner, we need to visualize the data with the series. We're going to visualize this data in form of a series. So to visualize this data in form of a series, we need to filter the data that can be visualized. In this manner, we need to visualize the marks. So to visualize the marks, what we need to do, we are going to filter it. And how do we filter the data that we want to work with? We have to pass on the data frame, which is having our data, and we pass a parameter marks here in this square. Then we are storing it in our filtered marks as our variable. Then here we are running the filtered marks. So this is now a series, because in a series we have only a single column and our index. Now that we have filtered the data here, after filtering the data in form of a column, because we need only one column and the index, now we have to convert this data into a series. Now we are passing the data here, filtered marks, and we convert it to a Pandas series. After converting, we are storing the stored data here. Now we need to plot the graph. And to plot the graph, we are going to call our matplotlib as plt.rc parameters here. So here we are just saying RC here, it stands for runtime configuration. This RC just stands for runtime configuration. And this contains the default styles for every plot element we are going to create. So, and here with the figure size here, it determines the size of the figure in inches. And also we can see that we have added an extension .dpi, and this stands for dot per inch. That is dpi. And this determines how many pixels the figure comprises. For example, here we are just setting it to 400. In this manner, we are setting it to 400. So now we are saying series dot plot, and we are determining the kind of graph that we want, which is nothing but a bar graph. So let us run our line of code. Right, as you can see here, we've successfully plotted a bar graph, and the marks are seen as follows. And these are just the index numbers to identify who's having these marks. And this is our bar graph. Now, in statistics, we have what we call, an attribute called describe. Describe, it helps us in statistics to have a deep understanding of the nature of the data that we are having. So, this describe is very important in data analysis. It actually explains in detail the data that we are having. For example, let us run our line of code. As you can see, we are having a statistical attributes, for example, that we are having here. We are having count. Count, its main purpose is to count the number of elements that we are having. In this manner, for example, here, we are having 5 elements or 5 observations. And in these 5 observations, these are the marks that we are having. In these marks, we are having a mean. And mean is an average. And the average mark that the students are having at average level, it is 55%. And if we are to calculate the standard deviation, we can actually see that it is 25. So this is just a statistical attribute or statistical data analysis that we are having. So once you pass on described class here or the described method, it gives you a statistical analysis of the data. Then you can explain or you can have a clear overview of the data that you are having. And also, you can have the ability to plot your graph or your chart as a pie chart. For example, if you are plotting a pie chart in this manner, if you are plotting a pie chart, you just call our series .plot.pie chart. We use this method pie. Let us run our line of code. As you can see here, this is the pie chart that we are having here. So if you are representing some information to your boss and you want to explain it in a 2D or in a 3D data presentation, you can use a pie chart. It is one of the charts that people normally use when interpreting data. It is very good to use a pie chart. So you just call the method pie. Now, to extract the data, for example, let us take a look on how we can extract data in a data frame. Remember that this is our data frame. We have 3 columns, which is name, marks, and grade, and we have only 5 rows. And these 5 rows represent the number of observations that we are having. And to filter data or to extract data, we just, for example, we want to extract only names. We just have to put the data frame or the data set, the name of the data set, square bracket, then you pass on the string or the column that you want to extract. In this case, we have extracted only the names by calling the data set, square bracket, then the column name. And also, you can use index. For example, index 0 here. For example, you can see that this is index number 0. So this will extract a single row, the complete row of the data on the data set. So I have to see this whole row. Let us run our line of code so that we can actually see. So we can actually see that the name is Fanuel M, marks 90%, grade it's A, which is actually depicted here. This is the row of the data. So we use the index also to access information on our data set. And if you want to retain multiple rows, we use the locate method or the locate attribute. So this is the locate attribute. It helps you to get access of the information on a given row. And this locate or locate attribute, you can pass also 2 parameters here, the starting point and the end point. So it gives you access to multiple rows. Let us run our line of code. As you can see here, we managed to get multiple rows from 0 and 1, as you can see here. So we can go here and we see that we get this and this. So the locate is very important and useful to use. Also, we can see that data frames are mutable values. This should be mutable. Data frames are mutable values. And when we say data frame is mutable, we are saying data frames are both value mutable and size mutable. So you can change values held within the data frame or add, even delete columns to the data frame. So let us start by value mutability or changing elements in a data frame. Let us change the marks of Fanuel from 90% to 80%. And as we can see here, Fanuel M is on the first row, which is index 0, as you can see. We can run our line of code. We can actually see that we have successfully changed the marks of Fanuel from 90% to 80%. And also, we can add row and a column on our data frame. Let us add the position as a column. So we call our data frame here, which is our data set. Then we are going to add this column position, and the position we are going to put a series of numbers 1 up to 5. Let us run our line of code. Right, as you can see here, we have successfully added position on this column. And another thing that we can do with the Pandas, we can add also a row in the data frame. Here we are saying we are going to add, and we pass index number 5, and we are going to add on index number 5, we are going to add this name, this marks, this grade, and this position. Let us run our line of code. Okay then. Now, as we can see, we have successfully added another row on our data frame. Now, let us take a look into our data frame again. Let us remove this first so that we can see our data frame. This is the data frame that we are having, and I want us to delete this column. So you say you pass delete method, then you delete, then you put a square bracket, then you make sure you pass on the column you want to delete, then you run your code. And as you can see here, we have successfully deleted this line of code. Also, if you want to delete again or to drop position, you remove position or to drop, you can use the drop method to remove position on the data frame. If we run the line of code, we can actually see that we have removed or dropped the position on our data frame. Now we are moving on to our last stage of this video, where we are going to look into binary files with Pandas. And these binary files, we are just only to look into one file called the CSV file. And a CSV file is just an extension of comma separated values. We are going to use a read_CSV method. So how to create a simple CSV file? We normally use an Excel file. So the first thing, to read a CSV file, we create a variable called data, then we call our module, which is Pandas, then the method read_CSV file, which gives us the ability with the Python interpreter to read the data in a CSV file. Then my file here, I've attached this file or this student performance file on this course. So you just go on a resource file and download this file. Now, this file is on my desktop, so you can see this is just a path and an extension .csv file. And this is my variable. So I'm running here so that we can actually see the data that we are having in our Excel file. So you can actually see here that we have 100 rows and 8 columns. Meaning, in data analysis, we are saying we have 100 observations and we have 8 variables. If you want to see only few data, maybe you want to take a short analysis on your data, you can only use this method data.head, where data is our CSV file, .head. You want to see only 5 rows. So once you run this line of code, you can actually analyze and monitor to see what is going on this few data. By running this data.head, you can see what is the nature of your data, and in this manner we can see it is student performance, and actually we are seeing mathematics score here. We can see the reading score, we can see the writing score. So the main analysis on this data is to see that does the mathematics score affected by the reading score, or does the writing score affect the math performance? That's the major analysis on this data. And also, does the mathematics score has to do with the person's preparation, or does it has to do with the lunch? Does the person ate something or not? Does it depends with the parent, either the parent has a degree or not? Is the parent is having a master's degree? What ethnicity does the parent belongs to or the person belongs to? So this is just analysis of student performance depending with these attributes or these variables in a given population. So if you want to see the last 5 rows of your data, you just use tail. So tail will give you a short analysis of the data that you are having. You can actually see a brief overview on the data. But if you want to get enough information about your data, what is going on within your data, you type the dataset.info. So if you run here, we can actually see that the range index from index 0 up to index 99. And here on the columns, which is our variables, we're having gender, race, and this as follows. So this is just a brief overview of the data or the information of the data that we are having. And if you want to see the length of the data, you can see here we're having only 1000 rows. If you want to make, let's say you want to make index, you want to change the index, you don't want 1, 2, 3 this index, you want to change the index to be a variable, the index to be a race or ethnicity. So you can set index as a column. For example, in your data set, you want the column, in this case, you want a column here to be the index. So this is how you set a column to be index. You create the variable, then you set index as then you pass on the parameter or the column you want to change. As you can see here, we can actually see that we have successfully made the column an index. Now let us take a look into filtering data. For example, you want to filter data which only having marks greater than 50, especially focusing on the mathematical score, on the math score. So what you will do, you create a variable called data_filter. In this variable, you call your data set, which is data. Then you put a square bracket for filtering. And you want to filter the data in this data set. Then you pass on the column that you want to filter data with using. Then greater than 50 outside here. Then you can actually filter the data. So as you can see, all this data here is the data around 850 rows. 850 rows are having students who are having marks above 50% in mathematics. And what if you want only to focus, because some of the data here, they are confusing you. You are seeing there is gender, there is race, there is parental, all these issues, you are not actually focusing with them. Maybe you want to focus only with math score, reading score, and writing score. So what you need to do, you need to filter this data, this column, you have to remove them, to filter them or to drop them. Since we have learned how to drop data, what we do, we create a variable x, and x is equals to our data set. And inside our data set, we are going to create a list. This is a list of the data that we want to drop, as you can see here, and our list, and here with writing score and reading score, because I want only to focus with the mathematics score. Now, data.drop. Then in this parameter, I'm saying x here, I need, this is the variable that I want it to be dropped. So I'm passing it here. So now we drop the data here. Let us run our code. So after dropping all these variables or dropping all these columns, we can actually see now that we are having one column which is math score and obviously our index. And now what we need to do, we need to filter marks which are less than 50. Let us run our line of code. And we can actually see that scores of mathematics which are less than 50, we have 135 observation or rows here. And we can actually see on less than 35, let us see the first 10 rows. We have some are having 47, 40, 38, even someone is having a 0 there. Right, so what I want us to do, let us go up so that we rerun our data so that we proceed. We go here and we run again. Now let us go back down here and let us run our file. Let us run here. So in this case, what we need to do, we need to plot a graph. And in this case, we need to plot a graph of gender and math score. So to plot a graph of gender and math score, we have what we did here, we have dropped the rest of other columns that we don't want to use. After dropping them, then we are having gender and math score here. So since we are having gender and math score and we need to print only the data of those attributes. So what we need here now, what we need to do, we create our index and we want to make gender is our index. So after making gender index, then x is equals, we want to only to do for 10 observations. So let us run our line of code. So now gender is our variable. So now what we can do, we can actually plot our graph. Right. We can actually see that this is the data for the gender as our variable, as our index, and the marks. This is just a general overview on how we can actually use pandas in data manipulation and data representation. I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.